Welcome to the introduction on the unit circle. The unit circle, what a wonderful phrase. Trigonometry, ain't no passing craze. Oh dear, let's move on. The unit circle, as it sounds, is all about a circle. But it's about a special circle, a circle that has a radius of 1 unit. The radius equals 1 unit, and that is the definition of a unit circle. If you've ever got a unit circle, don't forget its radius is 1 unit. So I've got a unit circle here, and I'm going to draw in an axis like this, so you can be drawing this as well. And in that axis, on those axes, I'm going to draw a triangle like this. That's a right angled triangle. Now, because this is a unit circle, I therefore know that the radius of the circle is 1. And so this is therefore going to be 1, that line there. So I'm just going to label that as 1, and you'll see why soon. Oh, let's get off highlighter. So that's going to be 1. And then I'm going to put an angle in here. So this angle, I'm just going to call it theta. Then I'm going to pick any random point on this circle. So I'm going to actually just pick that one there. Okay, pick that one there. And I could call that point X, Y. Okay, so I'm going to call that X, Y. But then I'm going to remember that I know my trig ratios. I know that sine of theta equals the opposite over the hypotenuse, and cos of theta equals the adjacent over the hypotenuse. I also know that tan of theta equals the opposite over the adjacent. When I think about that, I can go, okay, what's opposite sine of theta here? Well, obviously, it's this line right here. That's the opposite. But how big is that? Well, we're going from the origin up to this point here. And the y value of that point there is y, because I've just called it y. So we're going from 0 to y. So the distance we're actually travelling, if we think about it, up that side of that triangle is y. Similarly, if we're going across ways, we start at 0 and we're going across to that point there, we're going across to x. So therefore that distance must be x. So there straight away we have two values. We have the value for x and we have the value for y. So if we're doing sine theta equals opposite over hypotenuse, well, the opposite is now actually y. The hypotenuse is 1, so therefore sine y equals sine theta. Now very similarly, the cos of theta equals adjacent over hypotenuse. The adjacent is x, the hypotenuse is 1, so therefore x equals cos theta. So now instead of writing xy, I'm going to write that as cos theta and as sine theta. Okay? Hopefully you're happy with that. That point, instead of just writing it as xy, because I've proved that y is equal to sine theta and x is equal to cos theta, I can write that point as cos theta sine theta. Now tan of theta equals opposite over adjacent, and I've just worked out that the opposite is y, the adjacent is x, but y is equal to sine theta and x equals cos theta. So tan theta is actually equal to sine theta over cos theta. So now I've got this question. For theta equals 320 degrees, determine whether cos theta, sine theta, and tan theta are positive or negative. And you might be going, what? It's okay. Relax. You will understand. We've got a circle, bit of a wobbly one. But hopefully you can see if I travel this way and measure angles, I call them positive angles. If I travel that way and measure angles, I call them negative angles. That's just a convention you need to know. So if I've got this circle, it's really bothering me that it doesn't look like a circle, but that angle there is 90 degrees. If I'm starting at here and going to there, that's 90 degrees. If I go all the way around, I get to 180. If I go down to here, I get 270. If I go over here, I get 360, or 0 degrees as well. So if I'm thinking about 320, well, that's going to be somewhere in here. I don't really care about exactly where, but it's going to be somewhere in there. All right. Now I've just said that x is actually equal to cos theta and y is actually equal to sine theta. Interesting. So if I'm thinking there, well, if my angle is 320 degrees, so this is my angle, starting at 0, going around to 320, is my x value positive or negative? Think about it. It's in this region. And I'm sure if I got rid of cos theta and sine theta and something, you'd say immediately, x is positive. Of course it is. Well, we've just said that cos theta is x. So that means that cos theta is therefore positive. Now, similarly, with sine theta, we think, well, sine theta, that's y. So if I looked at this little bit here, is y positive or negative? Y is negative. Therefore, sine theta must also be negative. So sine theta is negative. And then with tan theta, I remember, well, that's actually equal to a positive over, that's equal to sine theta over cos theta, which is negative over positive, which is a negative, because a negative divided by a positive is a negative. Now, tan theta actually represents the slope, and if you think about it, slopes that go that way are negative. So that makes sense that that's a negative value. Alrighty, what about this one? Find the exact coordinates of P and Q. And then find the coordinates of P and Q rounded to 3 decimal places. Alrighty, well, we've got our circle here, haven't we? Our unit circle. That looks like this. Got it up here actually, so let's not redraw it. If we're trying to find the exact coordinates of P and Q, remember we said that any point on here could be xy, but we also said that any point on here, if we had a general angle theta, is cos theta sine theta. You were happy with that, hopefully, from before. So if we've got an angle, 212, well, that's really our theta. So that means that the exact coordinates of P are cos 212 sine 212. And the exact coordinates of Q, which is part A, are going to be cos negative 51 degrees sine negative 51 degrees, the x and the y. That's how it works. Now negative 51, it's fine to put it like that, or you could say that that's going to be the same as 360 take 51. So that's cos of 309 sine of 309 degrees. They're actually the same, because 360 take 51 is the same as negative 51 degrees. Then if we were going to work out what the actual coordinates of that are to 3 decimal places, well, you'd have to put that in your calculator and work out what the values are. So I'm just going to do that for P. I'm not going to do it for Q. You can do that. And when I get cos in my calculator, I get P is negative 0.848 for cos, and for sine I get, if I just quickly chuck it in, making sure of course that I've got my calculator set to degrees, I get negative 0.5299, which I'm going to round up to 530. Now when you get that, it's always worthwhile checking, does that make sense? If you think about it, P, look at P right here. P is in that quadrant, and if we think about it, x is negative, so cos of x is negative, and y is also negative, so cos of y, so sine of the angle is also negative. Makes sense? If your angle is actually in radians, just make sure you put it in degrees, and you do that by going shift menu. I'll write it down here just in case. Shift menu, so that's going to push you to setup. Then you just arrow down till you get to degrees and or radians. It's the angle. Okay, so you scroll down, and you'll push F1. Okay, so that's how you convert. But as I said before, always worthwhile checking if your answer makes sense. Now, this comes to the beautiful unit circle. The unit circle looks scary, but it isn't really. It's really logical. You know how we said before, we can have 0 there, and 90 there, and 180 there, and 270 there? Well, we can actually put in a whole lot of other angles. If we put 30 there, and 45 there, and 60 there, I'm going to go 30, 45, 60. Then at each interval, I'm going to add 30, 45, 60 again. So I'm going to do 90 plus 30, 120. 90 plus 45, 135. 90 plus 60, 150. 180 plus 30. 180 plus 45. 180 plus 60. 270 plus 30. 270 plus 45. 270 plus 60. There you go. There's a whole lot of perfect symmetry around the unit circle. These are something called the special angles. They're called that because if you put cos of 30 in your calculator, you actually get root 3 on 2. You try it. Put cos 30, you get root 3 on 2. So if you put cos theta in your calculator and then you put sine theta in your calculator, what you're actually getting are the coordinates of that point right there. Remember what we said before with our triangle. If this was theta, we call this cos theta, sine theta. So this root 3 on 2 here is actually where the line, the angle 30 degrees meet. And so that's cos 30, sine 30, sine 30. You put that in your calculator, you would get root 3 on 2 and a half. That's how the unit circle works. Cos 30 is root 3 on 2, sine 30 is a half. They're the x and y coordinates. Now we can go around to this angle and do exactly the same thing, and that angle will do the exact same thing. But once we've got those three, we don't actually have to worry about anything else. And you think about why? Well, you can get them all off those three values. We're going to draw a line straight across from here to here. What do you notice about the y value? If I drew it straight, it would have been exactly the same. Draw this line from here to here. What do you notice about the y value? Exactly the same. This line from here to here, what do you notice about the y value? Exactly the same. And you think about it, what about the x value? Well, this x value, that's root 3 on 2, positive root 3 on 2. If we go over here, it's exactly the same distance away. It's just in a negative direction. So that's now negative root 3 on 2. Okay, what about this one? Well, the y value is root 2 on 2. This is going to have the same y value, but it's going to be exactly the same y value, and it's positive still. But for the x value on this side is root 2 on 2, but on the other side it's going to be negative root 2 on 2. We can do that all the way around the circle and get all the coordinates of these points. You don't have to memorize this, but if you know how it works, it makes it really helpful to be able to use it. So how would we maybe have to use it? If we were to find the following values on the unit circle. This is a common question. You might get something like this. We've got our unit circle here to help us out. Find the following values on the unit circle. Sine 120. Well, that's a multiple of 60, so I'm going to be able to find it. I go over here, sine 120. There's 120. Sine 120. That's going to be the y value. There you go. The y value, root 3 on 2. That's all it is. What about cos negative 30? Well, that's a negative angle. That means I start here and go that way. I remember that this is 360, so if I take 30, I'm going to get to 330. Cos of negative 30, just go down 30. It's going to be that value there, root 3 on 2 as well. What about some other ones? Calculate without using a calculator. Sine of 585. You go, what on earth is that? Well, remember that 360 degrees is one revolution. So if we're doing sine of 585, we're actually doing 360 degrees. Back to the start, then off we go again. So sine of 585 is going to be the same as sine of 585 take 360, because after 360 we start repeating ourselves again. If we look at that then, we go 585, and we take 360, what we're going to get is 225. So that's going to be sine of 225 degrees. So then if I look at 225 degrees on this, I go over here and I go 225. There's 225 right there. Sine of 225. Oh, I can read that straight off there. Negative root 2 on 2. Easy. Negative root 2 on 2. Now if it's not on the unit circle, well then I can just put in my calculator. Tan of 120. Well, tan is sine over cos. So that's actually going to equal sine of 120 over cos of 120. And I'm going to find those values over here. So sine of 120, if I just erase my mess and look up here, sine of 120 is root 3 on 2 and cos is negative a half. It's this coordinate up here. So that's going to actually equal, see if I can squash it in, or might just arrow down here so I don't make a complete mess. Root 3 on 2 over negative 1 over 2. So I'm going to do far by far, which is, you could put that on your calculator, but I'm just going to multiply those two together. So it's going to be 2 root 3 over 2 times negative 1, which is negative 2. And so I get negative root, negative square root of 3. You might go, oh, how did you do that? Far by far, if you've got a fraction over a fraction, far by far divided by near always works. The answer to that is negative root 3. Cos of 480. Well, that's going to equal cos of 480 take 360, which equals cos of 120, which is negative a half. Why does tan of 30 equal tan of 210? Interesting question. And we compare it to tan of 210, you'll notice they're on the same line. Okay, so they are actually on the same line. And therefore, they have the same slope. And therefore the same tan value. So we can go same line, same slope, and therefore the same tan value. Finally, let's do tan squared of 45 degrees. Whenever you've got a cosine squared or tan squared or whatever squared, a trig function squared, that's the same as going tan of 45 degrees squared. Now tan of 45, because the angle at 45 has the same y and x coordinate, same cosine and sine, it's actually going to be 1 squared, which equals 1. It's just worthwhile knowing how to do those. You do the angle first and then square it. Should be good to go now.